Okay, g'day folks, welcome back. This afternoon we're going to have a bit of a revision on the basic rigging calculations. There have been some slight changes in it since the last video I put out, probably about 18 months ago. So we'll have a look at the changes, how it affects it. There's not a great deal in there, but there are a couple. There's one less formula we have to do, which is always a bonus, one less thing to worry about. The essentials of it is pretty much the same. It's all about the setup of a winch and all the figures you need in order to do that. So what we're going to do is we're going to have a look at it one step at a time. Now what you've got to remember is when we're talking about the calculations for basic rigging, a lot of people get stressed out about doing calculations. The main point of this is remembering the formula. If you remember the formula, all you then have to do is put the numbers underneath, jump on a calculator and come up with an answer. The actual maths or the arithmetic involved is pretty straightforward and you have a calculator. So it's not about maths, it's more about remembering the formula and what they're actually used for. If you can do that, it's all a breeze. So if you're stressing too much about doing the calculations in themselves, don't. What you need to do is remember the formulas. So if you can write out the formulas in the order that we use them and you memorize those formulas, so if you don't, just write them out 50 times on a piece of paper in the correct order. And when it comes time to do them, so long as you can write down that formula, all you then need to do is put figures underneath, jump on a calculator, and away you go. It is pretty straightforward, the actual arithmetic. It's just a matter of making sure you get that formula right. So we'll take a look at the formulas. All right, I'll find where I put my text up. Here we go. All right. So the first one we need to do is to work out how far away our lead sheave needs to be from the actual winch. So we're going to use a setup, something similar to this. So let's say we've got a winch here, comes across to a lead sheave, right, goes up here. Let's just get them out of the way. And then we got our purchase here. Right, and let's say we've got 6 sheaves in the purchase. Let's say we're going to pick up a load weighing 10 tonne, and we've got a 60-degree angle here. We'll work with a winch which is grooved, and let's say it's 1.2 meters. So we'll use those figures and we'll go through one step at a time. Now the first one, as I said, is to work out how far away this lead sheave needs to be from the actual winch drum. Now the reason it needs to be a minimum distance away is, if you could imagine it, we'll look it down from the top. If you've got your winch drum there and your lead sheave is right here, it's too close to it, what's going to happen is all that rope is just going to bunch up right in the middle of the drum. It's not going to get that nice even lay going across the drum. So we need to put that a minimum distance away in order for that rope to lay nice and evenly across the drum. Now, what you've got to keep in mind is if you have a grooved winch drum, so if you've got grooves in your winch drum that the rope sits in, this won't need to be as far away because the grooves will help guide it in. So if you've got a grooved winch drum, if we look at our centre line there and the angle out to the side, this angle at the top can't be any more than 5 degrees. Now if you have an ungrooved winch drum, it will need to be a bit further away. Now it's got to be further away because it doesn't have those grooves to help it. So with a ungrooved drum or a plain drum, this angle can't be any more than 3 degrees. So how do we work out how far away this needs to be to get those minimum angles? It's pretty straightforward. I'll grab my duster. Right, let's get rid of that. So this is where the first formula comes in. The winch drum So you've got your winch divided by 2, because what we're doing is we're finding out the distance from that centre line out to the edge, and it's going to be the same both ways. So that's why you're going to divide your winch in half, because you want it from the centre out. And then you're going to just times that by the fleet angle. So the fleet angle, well, your 3 degrees and your 5 degrees technically is your fleet angle. But what the figures we're going to use is if we have a grooved drum. So if it's grooved, we use the number 12, and if it's ungrooved, we use the number 19. Right, so to achieve the correct fleet angle, we need those two numbers. So grooved is 12, ungrooved is 19. So when we look at our formula, as I said, it's not about the maths, it's about remembering the formula. Because once you get the formula right, when we look at that, winch is 1.2 meters. So 1.2 divided by 2 times your fleet angle. Now you have a look and see whether it is grooved or ungrooved. Because we've got a grooved winch drum, we're going to use the figure 12. So times 12 equals. So if we have 1.2 divided by 2 is going to give you 0.6. 0.6 times 12 will give you 7.2. And don't forget, we need our unit of measurement. So a 1.2 meter winch that's grooved, you will need that lead sheave to be at least 7.2 meters away in order for that rope to lay nice and evenly across the winch drum. If it's too close, it's going to bunch up in the middle. It can be further, but that is the minimum that it needs to be in order to lay it on there. So that is the first formula. Quite straightforward. It's basically just the winch, which you halve, so divided by 2, and then you times that by the fleet angle. Remembering, if it's grooved, you use 12. If it's ungrooved, you use 19. Okay, on to the next formula. Let's get rid of this. And at the end, I will write all the formulas up and we can just have a look at them, or I'll put it up on the screen. Right, now the next thing you're going to get asked for is to work out the lead line in the winch drum. Now working out the lead line actually requires two formulas in order to do it. Because the first one we need to do is find out our Beckett load and then use that figure to work out our lead line. So the first one is quite simple. So the Beckett load is your load divided by the number of falls you have in your purchase. Now, to determine the number of falls we have in our purchase, or parts of line in the purchase, whatever terminology you want to use, all it is saying is how many times that rope goes up and down around that purchase. So this is your purchase, this bit here. Now, if we have 6 sheaves in our purchase, it's quite simple. You've got 3 sheaves at the top, 3 sheaves at the bottom. 6 sheaves means 6 falls, or 6 parts of line. So when we look at our formula, the load, which was 10 tonne, divided by the number of falls. So you just look at how many sheaves you have in your purchase. If you have 6 sheaves, you have 6 falls, which equals, all right, I'll just grab my calculator. Okay, so we've got 10 divided by 6 equals, okay, so we've got 1.6666 recurring, so 1.6666, etc. Now this is where some people get a little bit confused. It's on the rounding up. So what we need to do is round up to the second decimal place. Now, when you're in school, you learn to round either up or down, depending on what the figure is. But in rigging, we can't do that. So if you think about it, if you ended up with a figure for a sling, and it came out at 1.01 ton. You can't use a 1 ton sling to lift it because you don't round down. You will need to go up to the next one. So you always round up. Okay? So if we're rounding up to the second decimal place, that second decimal place will go up to a 7. So that will be 1.67. Alright, so quite simple. Second decimal place goes up. If you came up with an answer that only had 2 decimal places, then you just leave it. If there's nothing after that second decimal, just leave it where it is. If there is anything after the second decimal, well, that second decimal will need to go up 1. Alright, so our Beckett load is 1.67 tonne. Now what that means is if I have 6 parts of line in my purchase, so I've got it going up and down and around, and you end up with 6 parts, that basically means that each part of line in that purchase is each carrying 1.67 tonne. Now in an ideal world, that would mean that this winch will be pulling 1.67 tonne to lift that 10 tonne. Unfortunately, we don't live in a perfect world. We have this thing called friction. And what that friction is going to do is going to put that little bit of an extra drag on it. And that's what we've got to work out when we're working out the lead line. So what we do is we allow 5% friction per sheave that rope runs through. So to do that, to work out our lead line, the formula is going to be the Beckett load. Hence why you need to do the Beckett load first, because you need that answer. So Beckett load times the number of sheaves. Now this is the total number of sheaves, not just what's in the purchase. Okay, divided by 20 plus Beckett load. Now this is the only really long formula you've got to remember, and if you understand the reason for doing it, it actually makes it a bit simpler to remember. Alright, so essentially that bit there in the brackets, that will work out the friction, and then you just add that onto the Beckett load you had originally. You will come across some places, and I will actually say most places I've seen this formula, they have it written with the Beckett load plus and then the brackets. Now it doesn't matter, that will still work so long as in that instance you remember to do the brackets first. I like writing it this way with the plus Beckett load at the end, because when you do that you don't have to remember about doing the brackets first. All you need to do is go straight through on the calculator. There's no confusion. Another couple of variations you might see, instead of dividing by 20, because that's how you get your 5%, 100 divided by 20 equals 5. A common variation, a lot of places will say your sheaves, instead of divided by 20, they'll say times 0.05. Now that works out the exact same. If you had 100 times 0.05, you'll still end up with your 5%. I don't tend to use that one because what I find is when you start introducing decimal places, people tend to put it in the wrong spot. So if you divide by 20, it just removes that chance of error. Because quite often people will forget the 0.05 and they might write 0.5 or 0.0005, whatever the case may be. The decimal point just adds somewhere else where you can make a mistake. So if you just divide by 20, it sort of takes that out of the equation. Alright, so Beckett load times the number of sheaves divided by 20 plus Beckett load. As I said, if you can write that formula out, then all you need to do is put the numbers underneath it, jump on a calculator and come up with an answer. So Beckett load 1.67 times. Now this is where we look at the total number of sheaves in the system. So we already know we've got 6 sheaves in the purchase, but this winch rope also runs around this lead sheave. Right, so that's an extra sheave. So 6 sheaves in the purchase plus your lead sheave gives you 7 sheaves in total that wire rope is running around. All right, so 1.67 times your total number of sheaves. And then you divide that by 20, and then you add your Beckett load again, so 1.67. All right, then you grab your top trusty calculator, and you go 1.67 times 7 divided by 20 plus 1.67 equals, we have 2.2545. Okay, and I'm just going to do that a second time on the calculator. Always a good idea, because it's very easy to have fat fingers and press the wrong number. So if I was to be doing an assessment, I would want to make sure I put it in there twice, just to make sure that I haven't accidentally pressed the wrong number. So we'll go 1.67 times 7 divided by 20 plus 1.67 equals, there you go, I've got the same number. I'm going to assume that I haven't made the same mistake twice. Now, remembering, if we need to round up to the second decimal place, your second decimal place is a 5. We do have something after the 5, so that means our 5 is going to go up to a 6. So our answer will then become 2.26 tonne. Now, very important, the lead line. What you want to do, once you've worked out your lead line, I'll grab here we go, another colour. Once you work out your lead line, underline it, highlight it, do whatever you need to do, because what you've got to remember is that figure that we just worked out on the lead line, that is the figure you are going to use in every step after this. Now, one of the most common mistakes is people using the wrong figure in the wrong place. But once you've worked out your lead line, that is the important one you need to remember for every step after it. Okay. So the next thing you're going to work out, there's not even a formula. There used to be one for this, but it's been taken out, and we go on to one of these now. So we need to work out the minimum diameter rope we need in order to lift 2.26 tonne. So when you look at your chart here, okay, we've got our working load limit, and we run down here until we can lift 2.26 tonne. Right, so here we go. We can lift 2.3 tonne. You come across and you'll see that is a 16mm wire rope. Okay, so that one's quite simple. 16mm rope is the answer. You just need to look on this chart, run down until you can lift it, and then come across and it'll tell you what diameter rope. Alright, quite simple. Much better than the previous way where we had to do that extra formula. Alright, so what I'm going to do now is, the next two are really simple. Okay, so I'm going to get rid of this. I'm going to leave that lead line figure there, because that is the figure that I need for the rest of them. Okay. So the next one we want to work out is the head sling. So the sling holding everything up. This is one of the biggest mistakes people make out there in the real world. Because what they'll do is they'll look at something like this and they'll say, all right, that sling is carrying 10 tonne, so it needs to be good for 10 tonne. They might even say it's lifting 10 tonne plus the purchase, which may be an extra couple hundred kilos. So they might even say, let's go get an 11 tonne sling and that will cover it all. All right? They might think that 11 tonne is enough. But what we've got to remember is this sling, yes, it's holding the 10 tonne there, so it's got a dead load of 10 tonne, but you've also got this load being pulled on it of 2.26 tonne. So your head sling has to carry both the dead weight plus this other load being pulled on it. So your head sling or your head load, the formula is really straightforward if you remember what it actually does. So you remember, lead line is the one you use in everything, lead line plus your load. So our lead line was 2.26 plus our load, which was 10 tonne. Which means our head sling needs to be good for 12.26 tonne. So it's quite simple. The head sling, dead load, plus the load being pulled on it. Put them two together and that's what it needs to be good for. All right, let's just come down to one more, which is the load in the lead sheave. Now what the load in the lead sheave is basically, if I've got this anchored off, what does this anchor point need to be good for? Because you've got some pulling this way, you've got some pulling that way, you've got to figure out exactly how much load is being applied to it. So there's one figure here we haven't used yet, which is your angle or your angle factor. So we're going to use that on this last one. Remember, lead line is the important one because you use that in every one. And then it's simply times your angle factor. So lead line 2.26 times. Now if you remember in dogging, your angle factor for 60 degrees is 1.73. If you don't know how, if you can't remember your angle factors, once we've done this, I'll show you a nice, quick, easy way to jog your memory on how to remember the angle factors. A lot of people haven't been taught this, but it's a real quick and easy way to keep your angle factors up. Right, so angle factor for 60 was 1.73. Okay, so back to our calculator. We have 2.26 times 1.73 equals 3.9098. Right, now remembering our rounding up to the second decimal place. Okay, so that would make it 3.91 tonne. Okay, so that is quite simply it. You just need to follow those steps. It's all about the formula. As you can see, the actual arithmetic is quite straightforward, especially with the aid of a calculator. But if you don't remember the formula, it's going to make it very hard to get a right answer. All right, so let's get rid of this and I'll show you a quick and easy way to remember what your angle factors are. Let's get rid of that. Okay, so if you remember from dogging, there's three main angle factors that we use. Oh, we have 120, we have 90, and we have 60. Now, the easiest way to remember what the angle factors are, all you have to do is remember 1, 2, and 3. So if 120 is 1, 90 is 2, and 60 is 3. All right. If you've got access to your calculator, which when you're doing your assessments you should have a calculator there, the square root of 1 equals 1. The square root of 2 equals 1.41. And the square root of 3 equals 1.73. So if you're sitting there in the assessment and you've got a 60-degree angle and you can't remember the angle factor for 60 degrees. If you remember it's number 3, grab your calculator, press 3 and the square root button, and it will tell you what the angle factor is for 60 degrees. Doesn't work on any other angles, but it does work on those 3. 1, 2, 3, any one of them, square root button, and it will give you the angle factor for them. Okay, so I'm just going to write up here those formulas. You can have a look at them, remember them. If you're having troubles remembering them, grab yourself a bit of paper, just write them out in that same order, 20 times, 30 times, 50 times, 100 times, whatever it takes. But once you get those formulas down, the maths is going to be a breeze and you won't have any problems at all. Okay, so let's quickly write them up. Let's get rid of all of that. So our first formula was for the distance to the lead sheave, which is the winch divided by 2 times your fleet angle. And remember, your fleet angle is your 12 or your 19. 12 is the grooved, 19 is the ungrooved. If you can't remember which one's which, remember the grooved can be closer, so it will be the smaller number. So your grooved is going to be your 12. All right. Now remember, the next question you're going to get asked is to work out your lead line. So you're going to use the next two formulas to work out your lead line. First, you need your Beckett load, which is your load divided by the falls. Keeping in mind that the falls, or the number of falls, is essentially just how many sheaves you have in the purchase. Don't count your lead sheave, you use that in the next one. So your next one, which is your lead line, is your Beckett load, so you use the answer from there, times the number of sheaves. Remember, this one is your total number of sheaves, so it'll be how many's in your purchase plus your lead sheave. Divided by 20, that gives you your 5%, and then you add that back onto the Beckett load. That's really the only big long one. After that, they're pretty forward. But remember, do yourself a favour, when you work out that lead line, highlight it, underline it, circle it, whatever you need to do to get yourself to remember that that is the one that you need in the next formulas. All right. So the last two formulas are pretty straightforward. You've got your head sling and you've got the load in the lead sheave. All right. Remembering your lead line, so you can just start both of them with the lead line. Your head sling is your lead line plus your load. And the load in the lead sheave, well, there's only one figure we haven't used yet, which is your angle factor. So lead line times your angle factor. Keep in mind the easy way to remember your angle factor, and it'll be a breeze for you. All right, so it's all about those formulas, nothing to do with maths. Get those formulas down and everything's going to be a breeze. All right, so I hope that helps you, and thanks for taking the time to listen. If you want any more information, leave something down in the comments and I will try and get back to you. All right, thanks for your time.